Alright, I'm going to work out a bunch of the whiteboard review problems. So for the module 3, so hopefully it'll all work out great. This one's there's some fairly challenging problems in here, so this will be great for us. Alright. First one, it says translate this image, or find the image of ABC after we translate it along this vector v and then reflect it. So if you look at this particular vector, you can tell that the vector is moving over to the right 1, and then it's going up 1, 2, 3, 4. So this would be vector 1, 4. So we have to do exactly that to each of these coordinates. So the A coordinate, we're going to move it over 1, and then we're going to go up 1, 2, 3, 4. So this would be the new coordinate. This would be A prime. So A prime here, and then we would do the same thing with B. So we would go over 1, and then over 1 and then up 4. 1, 2, 3, 4. So this is where the B prime would be. And then same thing with the C. We go over 1 and then go up 4. 1, 2, 3, 4. So then this would be the C prime. Okay, so this would be the result after we just do the first transformation. Okay. Then we want to reflect it across the line L, and you can see this is the line L here, so we're going to make sure that we go the same number of units across that line. So this would be, oops, sorry about that, I was going to the initial. So we're going to go across that line, and so it's going to be, actually this will be in the same spot because it's actually right on the line. And then this C is just 1 unit away, so then we'll go 1 unit away on this side, and this will be C double prime. And then you'll notice that the A prime is 1, 2, 3, 4 units away, so then we're going to go 1, 2, 3, 4 units away from the line of reflection. So this is going to be A double prime. And so this point here is both, it's B prime and it's B double prime. And then we would connect those. And the red one would be the final result. It would be the image after those two transformations. Okay. And then there's another picture of it. Okay. Number 2, draw the image of ABC after this combination of transformations. So first, a 180 rotation about point P. So each of these points, each of these vertices are going to be rotated 180 degrees. So this is the angle 180 right here. So this starts it. So this would be 180 degrees, and exactly this number of units is where it would be on the other side of P. So that distance, it would be about, it looks like it would be like about right here. Same distance, so this would be C prime, and then the A prime, so then you would draw a line again from P to A, and then you would go 180 degrees, so then it would be roughly over here, and so then this would be your A prime, about over here. This will be better when we actually have coordinates, so the one on your syllab will actually have coordinates. And then next, B. So then there would be, it would have to be 180 degrees. So B prime would be up here, about here. And then, so this is what it would look like if it was rotated about this point 180 degrees. So each of those angles is 180. And then the next thing to do is translate it according to this vector. So this vector, it starts here and it goes over 2 and then down 2. So then we would have to do that to each of these points. So we would go over 2 and then down 2. So then this would be the A double prime. And then same thing for the B. We would go over 2 and then down 2. So then the B prime. This will be kind of rough. And then the C, we would go over 2 and then down 2. So this would be like our C double prime. And then we would connect those. Okay? Roughly. Alright. And number 3, what we want to do is we want to reflect this rectangle over the y-axis and then the x-axis. So if we do it over the y-axis, then it would be 1, 2, 3 units away. So this would be 3 units away here. So this would be the C prime. And then it looks like the D is 4 units away. So then it would be 4 units away here, so this would be D prime. And then you can see the B would be lined up here, 3 units away. So that's B prime. And then the A prime would be right here. So then we could draw that. So this would be reflected over the y-axis. And then we'd want to reflect it over the x-axis. And you can see that it's 1 unit away. So this would be 1 unit away, this would be 1 unit away, and then these other units are 1, 2, 3, 4 units away. So it would be here. And these coordinates would be, this would be D double prime, this would be C double prime, the one on the bottom right would be A double prime, and then this one would be B double prime, and then we could connect those. Okay? And then name another sequence of reflections that would produce the same thing. So what we could also do is we could reflect, instead of going this way and then this way, we could reflect over the x-axis first, and then we could reflect over the y-axis, and we actually would get the same, we'd be at the same spot. Okay? And then there's the sort of the digital of that. Okay, are the two figures congruent? If they are, then we should be able to come up with a good, transformation to make, or at least a rigid motion that would map one onto the other. So, any ideas? Do you have any ideas? So what we could do is we could reflect it. So let's reflect it over the x-axis. That's what that would be, right over this x-axis. So we would want to say yes, and then we could just kind of give an explanation. A prime, B prime, C prime, D prime is a reflection of A, B, C, D over the x-axis. So a pretty good explanation. Or if we were into giving rules, we could say x, y becomes what? If it reflects over the x-axis, then what would change is the y value. So it would be xy becomes x negative y. And that would also be a nice explanation. Okay. How about this one? Can we come up with a way to map these on top of each other? Well, possibly. So if they are congruent, we should be able to do that. So let's say for this one, let's say yes for this one. And let's say it's just a translation. So if you look at the B and figure out how to get the B on top of the N, it would just have to slide over 1, 2, 3, 4, 5, and then down 2. So let's see, it depends on which direction we're going, but it would have to be, yeah, over 5 and down 2, so we would say yes, and then triangle MNP is a translation. 5, -2 of triangle ABC. Or if you were good like what we were doing with the rules, you could say XY becomes what? We could add the 5, so we could say x plus 5, comma, y minus 2 would also do the trick. Okay? Alright, so this one, it says to give 2 different ones, but it's going to be great if we could just give one good way. So how could one figure map onto the other? Probably should say which one is going to what. So let's say we're starting with the ABC. So say we start with ABC, so let's start with this one. Whoops. So, this thing's acting funny. Okay. So start with this one. So this would be when we were doing that one activity, this is saying that triangle ABC is congruent to triangle DEF. So we want to figure out how could I get the A to lay on top of the D perfectly. So how could that happen? And then actually no, that wouldn't be the congruent statement. So because that would be it would be a little bit different because we want the vertices to match up, right? So this would be triangle ABC would be congruent to, because this kind of needs to flip a little bit if you look at the shape of it. The A is okay, but it looks like the B goes more with, it looks like it goes more with the F, like they need to be, like it needs to be switched. So let's say DFE. So this one really needs a reflection over the y-axis. So let's say reflect over y-axis, and then so let's go ahead and see what that would look like. So that would be here, this would be the B prime, and then 1, 2, 3, 4, 1, 2, 3, 4, so this would be the C prime, this would be the B prime, and then A would be 3 units over, so this would be A prime. Okay, so it would look like that. Okay, so it looks a little bit better, but let's say that they have to match up. So A has to land on top of D, and then of course B goes to F, and then C goes to E. So let's see, A goes to D, let's see how far it needs to go. It needs to go over 1, and then to the right, and then down 1, 2, 3, 4, 5. So this would be, that's a reflection over the y-axis, then translated by vector 1, -5. Okay? Or again, you could give like the coordinate rules as well. Okay, this one we want to figure out a way to make it happen as well. So let's say we start with the A, B, C, D, E, F, G, H. It has a ton of letters. So this one I think would be a rotation 90 degrees. So I know that one's a little bit harder, but I'm going to go ahead and rotate 90 degrees. And remember, when we rotate 90 degrees, we're always, whenever we say the degree measure, we're rotating counterclockwise unless we state otherwise. So counterclockwise. So what I'm going to point out is a couple of the measurements, or a couple of the coordinates. So this coordinate is -2, 1. And this one is actually a rule. So the rule goes x, y becomes -y, comma, x. So this point, for example, is -2, 1, and that would become -1, comma, and then -2. So this would be -1, -2, which would be right there. So this would be the new E, so that would be the E prime. And then the F, that one is -3, 1. So let's see, that would become -1, comma, -1, comma, -3. So that would be -1, -3. So that one would be the F prime. Okay? And then if you follow that same thing with each of those, then it's going to look like this. And they're all going to be rotated. So the whole shape is going to be rotated around that point 90 degrees. And you could even get like a protractor, and you could see that every single one of these degree angles from the old point to the new point is 90 degrees. And so it would look like this. It would be close. It still needs more work so that it would lay on top of the other one. So now it still needs to be translated over to the right. So then we would say, then translate, and so translate by vector 6, 0. Or again, you could use the coordinate rules, x plus 6, comma, y, because the y is going to stay the same. Alright. Okay, so now we get to 3.3. We're going to determine all the corresponding parts of congruent figures. So if these two triangles here are congruent, then we just start listing all the things they have, that are congruent. So for example, again, noting that the angles are the same. So the angles are, we would say, that angle K is congruent. See how the first letter is the same as that one? So angle K is congruent to angle G. Angle L is congruent to angle H, and then angle M would be congruent to I, since that's the last one. And then as far as the segments or the sides of the triangle, we would just start listing them again in order. So the first two letters, would go with those first two letters. So that would be KL. KL is congruent to GH, and notice I'm putting little segments above. And then LM is congruent, and LM, see, are the second two letters, the second and third letter, and the other one is the second and third letter. So HI, and then the MK. Segment MK is congruent, and you can see that's the third letter then going to the first letter. So then in the other triangle, that's I to G. And so those are all the ones that are congruent. Okay, the next question, it says if you had triangle BAT, which is not a bad idea to go ahead and plot. So I'm going to go ahead and draw it a little bit here. So you have BAT, so here's B, 0, 0. You have A, which is 5, 7, so you go over 5, 3, 4, 5, and then go up 7, so it's like about right there. So this is 5, 7, And then you have t, which is 0, 7, so that would be like, oops, about the same level here. So that would be t. So, and this is 0, 7, and this one's 0, 0. Okay, so then they make just a triangle here. Okay, so, sorry, that one's a little messy there, 0, 0 is that coordinate. Okay, so then it says that this triangle is rotated 280 degrees. So let's say it's rotated, somewhere here, 270 degrees. What's the size, or what's the length? Well, the length doesn't change, and so if you wanted to find the length of b prime t prime, it would be the same as bt, because of what we were just saying earlier, that if you do a rigid motion of any sort, the lengths are the same, and so bt would correspond with b prime t prime. So if you look at this length, bt, all it is 7 units up, because it goes from 0, 0 to 0, 7. So that's 7 units. So then the b prime t prime would also be 7 units. So both of these, so 7 would equal 7. So b prime t prime would equal 7 units. Okay? Alright, the next one has a whole bunch of letters, and really, to have any chance at this, you have to like totally, draw the rectangle. So I'm going to try to, or draw the quadrilaterals, and label accordingly. So I'm going to go ahead and do that. So I'm going to draw them, label them, and everything. So let's see. So give me a second. So A, B, C, D, and then I'll do this one the same. So I'll go E, F, G, H. See if I label these. I didn't do it exactly the same as this paper, but that's alright, should work. So let's say AB is 16, so let's label that 16. Let me back that one up, let me do a different color. So AB is 16, okay. BC, let's see where that is. BC, 5W plus 7, so that's 5W plus 7. Angle C is 2Z minus 1, so let's label that 2Z minus 1. And then angle D is 50, so we'll label that. And then in quadrilateral EFGH, EF is 3Y plus 1. FG is listed as 8. Angle G is listed as 80. And then angle H is listed as 2x. Alright. Find the values of x, y, and z, w, x, y, and z. So really it's pretty easy, like everything's supposed to equal each other, if they're congruent. So this is equal to this, so then that will help me set up the equation to solve for y. So let's do that one. So let's do 16 equals 3y plus 1. So then we just solve for y. So 3y equals, and we subtract 1, so that's 15. So y equals 5. Easy peasy, right? And then let's find another letter. So let's see. This one, see how this is in the same spot as this? The D and the H are supposed to be congruent. And again, when you're looking up at the congruent statement, the letters are corresponding, right? So the last letter is a D, so that D goes with the H, which is why these are congruent. So then let's set them equal. So we have 2x equals 50, so x has to equal 25. So there, we have x. Okay, let's find another letter. So let's find W. Notice this is in the same spot, these two, they're equal. So then we would say 5W plus 7 is equal to 8. So 5W equals, we had to subtract 7, so that'd be 1. So W equals, oops, I didn't mean to do that. That would be 1/5. Okay? What letter do we have left? It says Z, so where's Z at? Oh, angle C, okay, there we go. So we have this one is equal to this one, so that means that 2Z minus 1 is equal to 80, so that means 2Z equals, we add the 1, so that's 81. So Z equals 81 over 2, because we're just going to divide by 2, so 81 divided by 2, or 81 over 2, or even a decimal, what, like 40.5 or 40 and a half would be fine. Okay? Alright, we're getting there, we're almost done. Let's see, what does it mean for two figures to be congruent? It means that all of the, you can actually lay them on top of each other. So all the sides and angles have the same measure. So all angles and sides have the same measure. So that's important. And the other thing is, if they really are congruent, you have to be able to come up with a series of rigid motions to map one figure onto another. So you can come up with a series, or I'll say sequence, a sequence of rigid motions to map one figure onto another. Alrighty. Okay, let's see if I'm almost done. I think this is the last one I have. Explain what corresponding parts of congruent figures are congruent means. Okay, so that just means that if you have two figures that are congruent, that every single part that's in the same location, that they're all congruent as well. So we're going to just say that whoops, didn't mean to do that. We're going to say that the sides and angles, ay carabumba, oh well. I'm going to stop it there, and I'm going to say that the sides and angles of one figure have the same measure as the corresponding sides and angles of another figure. Okay? Alright, I hope you look at this and study a lot and do your review problems. Good luck on your Mod 3 celebration. Alright, have a good night.